All right, 7.2, part 2. We're talking about negative exponents. So you guys kind of already know everything from today. Just be kind of a review because you already know the rules of exponents. We talked about them earlier this year. We talked about them last year. So you guys should kind of already know this stuff. So the first thing you need to write is if we have any number to the power of a negative exponent, and we're going to make it a fraction just because we are dealing with fraction exponents anyway. So like a to the power of negative m over n, that's the same thing as 1 over a to the positive m over n. So put that in a box, that's important. And you guys already knew that, right? If an exponent is negative, it's like a bad guy, and we move the base with the exponent to the bottom, he like goes to jail, but then they provide therapy and becomes a good guy, right? State provided therapy. All right. So our first example, we are going to write an equivalent expression with positive exponents. Sorry, I'm using a lot of shorthand here. Right? An equivalent expression with positive exponents. And then we want to simplify if possible. And then we're going to do 5 examples. That's a 9, sorry. 9, sorry, there's a little tail on it. 9 to the negative 1 half. All right, so we're going to write it first with positive exponents. So we're going to make this 1 over 9 to the positive 1 half. So that's the first part of our answer. We just move the base with the exponent to the bottom. It's like going to jail. And then it becomes a positive exponent because he's in therapy. Good guy. All right, so then we want to see if we can simplify this. So remember that the power of 1 half really means that this is 1 over the square root of 9. The power of 1 half just means the square root. And can we simplify that? Do we know the square root of 9? Yeah, what is this? Yeah, so it's just 1/3. So that's the other part of our answer. It's simplified. And we don't ever want to write 0.3 repeating for that. Yeah? That's the 1 half, power of 1 half means a square root. Because it's like there's a 2 out here, but you don't have to write the 2 for a square root. All right, next example. Was someone saying wait? Okay. All right, so next example is 5xy all to the power of negative 4/5. So go ahead and write that with a positive exponent right now. And that's all you're going to be able to do, I think. Try doing that. We'll do it up here. This is warning 1, Clay. On the 3rd one, you're going out. You're going to have to just watch it at home. All right, so you should have written 1 over 5xy, still in parentheses, to the power of positive 4/5. If you left out the parentheses, you would have it wrong, because that would be saying the 4/5 only went with the y. And that's it. Like, we could try and do 5 to the power of 4/5, but I don't think we know the 5th root of 5. It's a decimal. So that's it, yeah? Oh, like with the radical notation? You can, but they're not making us do it here, so you don't have to. But you can if you really want, I guess. All right, 3rd example is 64 to the negative 2/3. Go ahead and see if you can do that one on your own. write it with a positive exponent, and then you should be able to simplify it. Oh, yeah. No, we don't need a calculator. Okay, let's check how you wrote it with a positive exponent first. So you should have written 1 over 64 to the positive 2/3. So you just make it move to the bottom and change the exponent to positive. Then we can think about this as 1 over the cube root of 64, and then we can square it, right? Because this number becomes this root, the index, and the top number becomes out here. So does anyone know, raise your hand, the cube root of 64? Liv? Sweta? 4, right? 4 times 4 is 16 times another 4 is 64. So this is really a 4 in here. So this is really 1 over 4 squared. Everybody, what's 4 squared? 16. So it's just 1 over 16. Good. So you should have gotten 1 over 16. All right, 2 more examples here. All right, example D is 4x to the negative 2/3, y to the 1/5. So on this one, since there's x's and y's, all we're going to do is just write it with positive exponents. So I think only one of those 3 factors is a bad guy. Who's the bad guy? The x. The x is the bad guy, and he's going to have to move to the bottom. So this is the only bad guy. So the other stuff gets to stay on top of the fraction. They're already on top because it's technically over 1 right now. So 4y to the 1/5 gets to stay on top because they're good. And then x moves to the bottom, and he goes through therapy and becomes positive 2/3. That's it. We can't really simplify because we don't know what x and y are. And then one more. It is in parentheses 3r over 7s. That's an r up there, sorry. And then all to the power of negative 5/2. We're going to have to review a concept that we learned in our other unit. That was a long time ago. That was like around Thanksgiving time we did this unit about all the exponents. So on this one thing that you might have forgotten is that if you have a fraction all raised to a negative exponent, do you guys remember this? You can flip the fraction over. So we can make it 7s over 3r, and that makes it a positive exponent. So if you have a big fraction all to a negative exponent, you can flip the fraction and it becomes a positive exponent. And that's all they wanted was a positive exponent, so we're done. We're like 30% done with our notes. It's not that long. It's not too long. Okay, so now what we're going to do, unless you have any questions, is we're going to review the laws of exponents that we learned last year, and then we talked about them this year too. So there's 4 laws of exponents that we're going to review. We already reviewed the one about the negative exponent. So the first one is if we are multiplying a like base and they have different exponents. So like 3 to the 2 times 3 to the 5. Do you guys remember what we do with our exponents in that case? You add them up. So this is just a to the m plus n. Good. So if you're multiplying with the same base, you add the exponents, keep the base the same. All right, second one that we need to review. what if we are dividing, remember a fraction is division, so we're dividing with the same base. A fraction is division. We subtract the exponents. So this is a to the top minus bottom, m minus n. So this is just review. I know you guys know this, but we're going to like work with harder problems with fractions. And then third one, there's four total, is if we have a power to a power, like a to the m raised to the power of n. What do I do? Add them or multiply them? Multiply them. So this is a to the m times n. Yeah. And then last one is when we have a product to a power. So that's when we have like a times b or ab all raised to the power of something like m. And so in that case, we can kind of distribute that power. So this is a to the m times b to the m. So if these are being multiplied in here, you can distribute the power. If this was a plus, you could not do that. You guys always think you can do that, and you're going to think it for the rest of your life for some reason. But you can't do it. If you have like a plus b to the m, you cannot distribute this. No, you can't. You can't distribute it. Okay? Don't do it. Well, so say you had like a plus b squared. That means you'd have to do a plus b times itself, right? You'd have to do a plus b times a plus b, and then you'd have to multiply it all out. You guys know how to do it. It's just sometimes you guys think you can distribute it. Alright, so let's do some examples. So for this example, the instructions are use the laws of exponents. Use the laws of exponents to simplify. And you guys are going to have to work with fractions, and I'm not going to let you use a calculator. You guys can do these fractions. Your high school teachers are going to be mad if you guys can't do these fractions. Fractions are just like a number. They're just any other number. They're fine. It's like, if you understand fractions, it helps you so much in life, too. Like, even with just things like, I don't know, making pancakes, yeah. I was just thinking about that this weekend because I was making pancakes. Yeah, but like this weekend I was making pancakes and it needed 3/4 of a cup of the mix, but I was only making half a batch. So I was like, good thing I understand fractions and I know how to cut 3/4 in half.
What is 3/4 in half?
3/8. Which is just
Yeah,
what?
yeah, 3/4 is
Well, you guys better get this figured out before you graduate high school, because you don't have it figured out yet. A lot of you.
that's right. Fill a 3/4 cup halfway.
That's what I do. Whenever, if I'm cutting 3/4 of a cup in half, I just think, no, I do. I just think, well, half of 3 is 1.5, so I just need 1.5/4. So I fill up the fourth cup, and then I fill it halfway up, and then you're done.
Or you could just get the 3/4 cup and fill it in half.
I don't have a 3/4 measuring cup.
You don't have the ones that are like 1/4, 2/4, 3/4, and a half.
You have a 2/4 measuring cup?
Well, it's a half. 2/4. You know what I mean, Miss Miss.
All right, write this one down.
You know what I mean.
A lot of measuring cups, they just come in, like I have two sets, and they both just have a fourth, a third, a half, and a cup.
Mine goes 1/4. Mine goes 1/4,
Okay,
1/2,
okay.
3/4.
All right. All right, we can tell who's getting ready to be a high schooler right now. Because middle schoolers like to, whenever something comes up, they like to tell their story relating to that topic, even though no one's listening to them. Like, they're just shouting it out into nothing. No, I wasn't. I wasn't listening to any of you. Whenever you guys start doing that, I just turn off my ears to everybody. All right. So we've got 3 and 1/5 times 3 and 3/5. Raise your hand. What should I do with the exponents? Raise your hand. What should I do with the exponents? Okay?
Add them.
Add them. So we're doing 3 to the 1/5 plus 3/5. Raise your hand if you can tell me what 1/5 plus 3/5 is. Liv? 4/5. 3 and 4/5. Fifths. That's it. Yeah. Because that's the rule that we've learned about exponents. No. Okay, Cameron, you need to go back and rewatch the rules of exponents videos. Okay? I'm not kidding. You need to. All right. Second one, a to the 1/4 over a to the 1/2. So remember, this means divided. So raise your hand and tell me what I should do with those exponents since I'm dividing. You can have a fraction exponent in a fraction. Yes. Liv? Yeah, we subtract. A to the 1/4 minus 1/2. This one we should know in our head, I think. Who can tell me what 1/4 minus 1/2 is? Audrey? Negative 1/4. Good. So this is a to the negative 1/4. Now, can we write an answer with a negative exponent? No. So we need to move this guy to the bottom and have it be a to the positive 1/4. Two more examples and then one more section of notes. Two more examples and then four more examples, basically. All right. Next example is 7.2 to the power of 2/3. And then all of that is going to be raised to the power of 3/4. Don't say anything yet. So this one we've got a power raised up to another power. Raise your hand if you can tell me what I should do with those exponents. Power to a power. Cameron? Multiply them. So we're going to do 7.2 to the power of 2/3 times 3/4. And we know how to multiply fractions, right? Okay, we just multiply the numerators and then we multiply the denominators. So this is 7.2 to the 2 times 3 is 6. 3 times 4 is 12. Can I simplify 6/12? What is it? 1/2. Good. So this is just 7.2 to the 1/2. And then last example before our last section is, in parentheses, a to the negative 1/3 times b to the 2/5, all of that raised to the 1/2. So all we're doing is simplifying this. It doesn't say we have to write it in radical form or anything, although at some point you might have to do that. So first of all, what can I do when I have a product raised to a power? What can I do with this power? Can I distribute it or not? I can because it's multiplying. If it was a plus or minus, I couldn't. So we can distribute this 1/2, and now we have 2 power to a power, right? So for the a, let's start with the a. What am I going to do with the negative 1/3 and the positive 1/2? Multiply them. So I've got negative 1/3 times 1/2. I'll deal with that in a minute. And then let's do the b. We're going to multiply 2/5 times 1/2. So we're taking a half of 2/5, which we should know what that is. A half of 2/5, 1/5. So now let's go ahead and multiply those. So this is going to be a to the negative 1/6, and then b to the 1/5, because we're taking, wait, oh, why did I write it 1/2? So we're taking a half of 2/5, which is 1/5. If you didn't know that, you could multiply them 2/10. That's why I was thinking 10. And then 2/10 is the same as 1/5. Okay. Oh, right.